Hello and welcome back to my workbench. It is time once again to try to fix something. And today on the workbench we're taking a look at a PS5 main board, an EDM-020 to be exact. And this was sent in by a viewer of the channel. I agreed to take a look at it. A gentleman named Robert. And he sent this in. And I'm not really sure the full backstory on it. If it was a dead one, I'm not sure. But I do know he has worked on it, and he sent me several pictures of the areas on the board that he had worked on. I think looking for a missing power rail. And in the process, I think he knocked off several capacitors. But from the pictures he sent, I don't think any of those capacitors are going to be critical. So I'm not really too worried about replacing them right now. If we can get this going, then I'll pull them from a donor, transfer them over, and put it back like it was from the factory. But right now we need to figure out how dead this board is. And I think to start with, what I will do is connect 12 volts to it and see how much current it draws. So let me see if we can do that right now. I can turn the board this way so that my leads are over here out of the way. Check your polarity, looks good. Let's see, 12 volts, half amp, should be plenty. See how much current draw we get. Ooh, 230 right off the top and then 0. See that again. 230 and then 0. That does not look normal. Looks kind of like a short. So that's likely what it is, a short somewhere. Let me get set up with the microscope and multimeter, and let's see if we can find this short, shall we? All right, let's start off by taking a look around this DA9065. Just see if we have anything obvious going on. I am in continuity mode, as you can see. So we're looking for shorts. We're on the hunt for shorts. Let's see, black probe on ground. This should be the 1.15 rail. No short, 3.3. Nothing there. 5 volts going in. Pretty sure there's no short on that. So, and we have pad here, this capacitor here. I believe this is 2 volts here. Or 1.98, no short. That's ground on that side probably, isn't it? No, that's ground on that side. So, no short. All right, what about on this side? Nothing. And here, oh, there we have a short. 1.28 ohms. That looks very familiar. I believe that goes straight into the south bridge. Right down here. Let me flip the board over. You can see there's been some work in this area. A lot of the crystal swimming in flux. I have to clean that up. But these little coils going into the south bridge are what we're interested in. And one of these, I believe, is that rail that we just saw shorted. Is it this one? Yes. It's that one. So yeah, I believe that's a 1.8. I'm not sure. It's a switch voltage out of the DA9065 that powers the south bridge. And that is shorted. Okay, there. Okay, there. There. So yeah, there's one of those, I think, capacitors that got knocked off, and there's some trace damage. Might have to take a closer look at that, compare it to a working board. But for right now, I think we need a south bridge. A definite short. I mean, this is where they seem to short for me on this. Was it this one? Which one was it? This one. Right there. That's where it seems to show up most often. I did south bridge. So let's get that, we'll get this board on the preheater, get that south bridge removed and changed out, and see what we have at that point. Well, our south bridge has been changed. Let's see if we've done any good whatsoever. Check polarity. Board is cooled off. Let's see what we get on current draw. Ooh, we went into current limiting. Going into current limiting, and I have a 1/2 amp of current set for the limit. So, that south bridge was definitely shorted. But we have another problem. Drawing over 1/2 amp of current on startup. Okay, what's that about? Alright, so we have a short somewhere. I've been looking around the board, and I want to show you what I found. We're going to be looking around the back of the Wi-Fi Bluetooth module. So let me get set up for that. And get everything in the shot here, kind of, sort of. So I'm looking at things that, that are powered up during that initialization, during the startup. What gets power, and one of those things is the Wi-Fi Bluetooth module. And looking around that capacitor, there's a little bypass capacitor here in the corner. If I can get up where you can see it, but basically there are 2 rails going into this Bluetooth Wi-Fi module, 1.8 and 3.3. And I'm not sure which one this is, but 2.6 ohms is not normal. And what about these other ones? That's ground. Okay, that one's in the KM. So one of them is shorted, one of them isn't. And I don't remember off the top of my head which one this is. But I think we can find, where's that rail come from? I want to say right over here. One of those rails at least comes from this little, you see a little DC-DC converter right in this area. Let's see if we have that same 2 or 3 ohm short in that area. Is that ground? No, that's in the K ohms. So it's not going to be that one. Let's see, I think this is 5 volts going into it. Yeah, about the same as this right here. No, I think that's the 5 volt input right there. And I think this is the output. Let me just see if I go to continuity mode and go right over here. Yeah. Is that right? Is that ground? Well, that's ground. Never mind. This side. So that is that rail. So this is the rail that's not shorted right here. So where's the other one come from? And I can't remember if there's a separate 3.3 volt supply or if it runs off of the main one. Just look the board over here. And I don't think that's it. I think that's a 2 volt supply of some kind there. I seem to remember. So does it? Well, that's what continuity mode's for. This is 3.3. Does it connect straight down here to this? It does not. So is it a switched 3.3? That's what I'm thinking. 2.6 ohms. So that's it. That's the one that's shorted right there. I'm right there on the capacitor. This little tiny bypass cap right there behind the Wi-Fi Bluetooth module. Where does that come from? I don't know. Oh. No. I'm thinking it's off of this DA9065, but I'm not sure. Oh. What pin is that off of? It says 3 ohms. Let me look at some notes. Just a second. Let's look under the microscope. I am somewhat confused. Let's see. Oh, I think I hit ground is what I did. Let me see. I'm going to that top of that cap, and I thought it might have come from this DA9065. Oh, that's ground. Yeah, that's ground right there. So that's not it. Where does it come from? Oh, is that ground? Yeah, that's ground again. The problem is that, the top side of this cap, the positive side of it, is 2.6 ohms from ground, so when I hit ground, it beeps. That's ground. I'm not finding it. Where does that come from? Is it switched by the south bridge? I don't think I've ever chased this down. Does not seem to be this other DC-DC converter I was looking at over here. That's one of them. Let me get out a working board. I think I've got a working EDM-10 or EDM-20. Let's take a look at that. So I'm curious where this is coming from. It's the kind of thing you need to know. Okay, so here's a good working EDM-10 board, which I think has the same layout pretty much. I'm going to give it 12 volts. This is a working board. I just want to try to remind myself what this little DC-DC converter here puts out. And it puts out 1.8, which is probably what is right here on top of this little capacitor. That's 3.3. What is this one? This is the one that was shorted on the other board, 1.8. So is it the 1.8? It must be. I think I knew this, but I tend to forget. 1.8. So it's a 1.8 volt rail going to the Wi-Fi Bluetooth module that is shorted. And the output is right here on this inductor. Yeah, okay. Let's go back to our other board. I thought I did not measure a short there. Okay, get this in the shot. This is our bad board. Right. Oh, it's a different layout. Yeah, this circuit's actually laid out a little different. But no short there. It doesn't seem to have a short. I have to get on an EDM-20 board so I can compare. Well, you know what? Let me see if I have one. Pretty sure I do. This is my known good EDM-10. And I think in this other bag I have right here, What is this? A known good EDM-020. All right. So now we can compare apples to apples. So if I go, turn the board the same way to start with, it's a band board, but it doesn't affect readings. Is this the same layout? I believe it is. No, short. So I have a short. No short there. 2.8 short on the 1.8 volt rail, 2.8 ohms. 200 ohms is normal. So is this converter not directly connected to it? That's what I'm feeling. Is it switched in some way? Because I am not finding. That's ground. That's not. I'm not seeing that 2.5 ohms short over here. That's what's messing with my head. Which kind of makes me think it's switched in some way. And I don't think I've ever followed that. I'd like to know that, though. Where does it come from? Like, so if this is 3.3, is that straight off of the DC-DC converter up here? Does not appear to be. It's switched in some way. This is ground on this side. So that seems to be switched. Okay. All right then. I think I know what's going on. I think I figured something out. It's very confusing. If I can show you. This is the EDM-10 board I'm comparing to. This is my good working EDM-10 that I thought was laid out just like an EDM-20, and I think I was wrong about that. If I can show you, there's a DC-DC converter here, and there's one on the other side of the board over in here somewhere. On this board, this little converter takes in 5 volts, and let me give it some power. Output's 1.8 for the Bluetooth Wi-Fi module. So that is connected to this capacitor right over here. Okay. And this module also gets 3.3. And that comes from right here. And if I put my meter probably right in there and give it some power, 3.3. And that goes to the Bluetooth Wi-Fi module. Okay? So, disconnect this. That's a 10. Go to an EDM-20. It does appear that Sony decided to change things around, and they didn't even tell me about it. In this same area, you have another DC-DC converter just like on the 10. But this one is for the Bluetooth Wi-Fi module. And this is our bad board, by the way. One that's shorting out. If I get on the output of this DC-DC converter here, give it some power. I reversed my leads. Damn it. I hate when I do that. What do we have? All right, now we're cycling. We're cycling. Let me get on the output of the converter. 3.3. 3.3. Where the other board in that same physical location had 1.8. So this is the 3.3 for the Bluetooth Wi-Fi module. And on the other side of the board, right here, in the location where the other board had 3.3, I believe this is the 1.8. And if we check from ground to, I think, this output right here, 2.7 ohms. So they swapped the locations of those DC-DC converters for the Wi-Fi Bluetooth module. I don't know why, but they did. And that's what was really messing with my head. So anyway, yeah, we have a short. Well, it could be here. It could be on the back of one of these little. It could be the module itself. It could be one of these capacitors. But we know the fuse is good because it's, you know, cycling up and down. There you go. Fuse is good. So we have a short on the 1.8 volt rail for the Bluetooth Wi-Fi module. So I have to get set up to inject a volt or so in there. Let's just see what would get hot. It could be the module. It could be a little capacitor here. It could be the DC-DC converter here. Could be one of these tiny capacitors on the back. I've seen those, you know, short when you have roaches that have been crawling on the board, but this doesn't have any roach damage. It's clean. So I don't think it's roaches this time. So we have to find it though. Well, I think I'm set up to see if we can find this short with the thermal cam. I've got it. Had to charge up my phone and the my thermal, you know, camera, and I've got my second channel. My power supply set up for 1.8 volts at 2 amps. Now we're not going to get 2 amps because you think about it, we've got about a 2.7 ohm short to ground, and only 1.8 volts. We're not even going to get a watt. I'm not even going to get an amp of current. So I'm not sure if it's going to be enough. I guess we will find out. Let's see. Let's see if we can get this recording. All right. Can we get some heat? Turning on the second channel now. 1 amp. So we're getting, well, we're getting 2 watts. 2 watts. Now, are we getting anything warming up anywhere? Maybe something on the other side of the board. Take a glance at the other side of the board here. Looking at those caps over here. Oh, okay. Yeah, that looks like the entire Wi-Fi Bluetooth module putting out heat. This is the back of the board. So it's seeing the heat through the board, radiating off of that Bluetooth Wi-Fi module. So it's the module itself, it looks like, not an individual capacitor. Okay, let me get this board kind of propped up here if I could. Yeah, and we will turn off the power and see what happens. See if it starts cooling off any. I guess I could put the crosshairs on it. Yep. And if I turn it back on, power is back on, temperature is rising again. Okay. I've seen enough. I believe we need a module, J20H100. I hope I have one. Well, our Wi-Fi Bluetooth module has been swapped out, and I want to confirm we no longer have a short. I can get a good ground there, and we should have about 200 ohms on this 1.8 volt rail into this Wi-Fi module. 197, I'll take that, and the 3.3 right beside it there. Be careful not to short between these two. That would be shorting 3.3 to 1.8 volts, and nothing good can come from that. So for right now, I'm powered down. That one we have, in the K ohms. That looks good. We're not shorted anymore anyway. Let's see if we can figure out what kind of current draw we have now. What kind of current draw do we have now? Polarity. Let's see what we get when we give it 12 volts. 300 milliamps and come back down. That looks encouraging. That looks very encouraging. I think this board will work. Only way to know for sure is to get out a chassis and pop it in there. So let me see if I can find a chassis. I would like to see it turn on before I, pronounce it being healed fully. So, all right, let me rummage through my parts and see if I can find another chassis. Okay, I did find a chassis to slip it into. This is actually to a 1015B digital, but doesn't really matter for the purposes of testing. I'm pretty sure this is it's got the connection to the Blu-ray board. Let's just see if we have any signs of life now. I didn't hook a fan up. Darn it, forgot the fan. Blue light flashing. We have video. Excellent. That's what you want to see. That's what you want to see. I do have a few more capacitors to replace around this board. I know Robert had mentioned that he had knocked some off. They're not really all that important or consequential, but while I have it, I will go ahead and replace those. But yeah, I think she's going to live again, Robert. I think I'll just go ahead and end this one here, unless you want to see me replace some capacitors. Decisions. I do have a few of them around the board to replace, though. Maybe I'll do that. But it looks like it's going to come back to life. Alright, well, I did replace two small ceramic capacitors. I thought there was going to be more missing capacitors. Just two tiny little capacitors. Pulled those off a donor and slipped it back in the chassis with the fan this time. And I got it running a game that was installed, GTA 5. And it seems to be working fine. It's charging my controller. Everything looks good. So I'm going to end it here. And Robert, this thing will be back on its way to you as soon as I can get it to FedEx. And I hope all of you out there liked this one. Thought it was somewhat interesting, educational, entertaining, any of the above. If you did, please give me a thumbs up. And I'll see you in that very next repair. Bye for now.